I'm Wed, co-founder of the 19th Group, and we're here at our headquarters in the Hardy Lab in the engineering building. Here we were tasked with addressing an important issue, truck slippage due to weight loads. To address this issue, we chose to design an electric motor vehicle that can go up a ramp under a load in a specific point of time. To do this, we first had to define our problem, which will take us over here to our problem definition. For functions, we had it that it must travel up a slope of this length in that time constraint. It also must carry a minimum load of this much. For our constraints, we had that its dimensions must fit the following constraints, and that it must have exclusively 3 AAA batteries and nothing more or less. Also, it must use at least one electric motor that's powered by battery. Next, we had our objectives. We wanted to prioritize cost, towing capacity, emissions, and appearance. We wanted to minimize cost, maximize towing capacity, and minimize emissions, while also making sure that our car looks good. Now, to make sure we're optimizing our objectives as much as possible, we had to do a lot of research, which brings us over here to Hafsa, our research lead. With her help, we were able to research many things to optimize our design, such as maximizing battery usage, improving motor performance, or maximizing our aesthetics. And with that research and that problem definition, we were able to come up with these 4 designs. We had a compact frame, front-wheel drive, a narrow all-wheel drive design, a wider rear-wheel drive design, and a wider, again, 2-motor wheel design. Now, how do we choose between all of these designs? We come here to our weighted decision matrix, where we placed all of our objectives and graded all of our designs against those exact objectives using these weightings, where we prioritize capacity over everything else. Following this, we were able to find that our all-wheel drive design was our most effective design, which brings us over here to Vince, our drafting specialist. He was the one that was responsible for getting most of our drawings done, as well as the assembly drawings, and ensuring that our drawings had the quality to be approved as working drawings. And this leads us to our manufacturing. For now, I'll hand it over to our manufacturing lead, Dwight, who will tell you all about our manufacturing process.
Hello, right now I'm drawing our layout for our truck. So this is how big it'll be. Our motors will be attached right here and right here. Next, we had to cut our axles to the right length, connect them to our wheels and our axle connectors, which connected to our motors, which connected to our main frame. Once we finished this, we were able to test our design, which, as you can see, didn't work out. Our motors were faulty, so we had to get those changed before painting. Finally, we were able to paint our design to make it look much better than it did before. Here we got our final design. As you can see, it's quite sleek. Great design. We have loaded 1.5 pounds onto it, and we will test it to see if it will go up to the ramp in under 30 seconds. After testing, we had our competition where we carried 2 pounds and finished top 5 in the class.